going to move on to the next presentation, which is from Aws Iot. We have the CTO, Jigar, and also Bill, the VP of Engineering. So please, let's welcome both of them.
Hey guys, thanks for having us here today. My name is Jigar Patel, and this is Bill Gloff, and we're here with Aws Iot today. We wanted to talk to you guys about how we're using AWS services to support real-time communication over cellular vehicle to everything. Before we get started into the tech, I just want to give a background about who we are and what we do. Aws Iot enables safer, faster emergency response for public safety. And we got started back in about end of 2015. At the end of 2015, when one of our co-founders nearly got struck by an ambulance as he was driving his motorcycle down North Avenue here in Chicago. He had his helmet on. He didn't hear the ambulance coming. It had sirens on as well as its lights on, so he didn't see the lights either. He came into the office and told us about this near fatal incident that he had. And when we started talking about it, us being tech guys were like, "Hey, go get a nap," and problem solved. He actually started looking into the issue and realizing that there wasn't any solutions out there today outside of antiquated lights and sirens to alert you of emergency vehicles. So since then, we spent about over 1,000 hours in the field working with first responders to understand their issue, understand the fact that people are not getting out of their ways and people are not seeing sirens or hearing sirens or seeing their lights. So we've built products and solutions now that are for emergency response. The fact is that there's over 60,000 collisions involving emergency responders per year in the U.S. And the problems and the fact for fire, police, and emergency personnel, they actually face a higher risk of death or injury traveling to a scene than at the incident itself. So these incidents are happening every day. When we start considering the autonomous vehicle and connected cars, the problem is just going to become worse. So it's an issue that we need to address, and these vehicles need more input from data outside of just being able to hear and see sirens, as there's nobody there to listen to that or see that. So Aws Iot streams safety information in the form of real-time digital alerts to drivers and connected cars via in-vehicle systems and smartphone apps when emergency vehicles are approaching or on scene. Here's a mock-up of what we're working on with the automotive manufacturer to stream in live safety data into the infotainment system powered by Aws Iot. Envision you're in a car driving down the road with your music on, and there's an emergency vehicle coming at you from the left at a blind intersection. This would be something to the effect of the music dimming and audible telling you that there's an emergency vehicle, and you also get a presentation inside of your infotainment center. So here's another example of what we're doing today with Waze. We've integrated a live feed into Waze of where emergency vehicles are when they're on scene. So we have a full suite of APIs that we can use to integrate into other data ingesters as well. In this example, the emergency vehicle arrived at a scene. We identified that there was an incident at the scene through our safety cloud and provided that information to Waze, and they displayed it on the infotainment center, alerting the driver of the incident. So our system mainly comprises of three components. We have the first component is our emergency crews. So we have data that's generated at the source and broadcast to our safety cloud. We have apps, IoT devices, and APIs to bring that data into our safety cloud. Once it's in our safety cloud, we're able to process the data, millions of records a day, and identify what actions to take. Last is our drivers, and they get an advance warning of encountering an emergency vehicle when they're en route or at scene. So this isn't last-second crash avoidance, something like DSRC or onboard sensors would provide. Our goal is to give motorists a 10 to 20-second advance notice that you're approaching an incident and to be alert. This enables safer, smarter driving decisions by the end user. So here's an infographic of the types of things that we're enabling and the types of data that we're bringing into our safety cloud. So not only are we enabling the emergency vehicles, but we also have other types of vehicles on our platform, such as sanitation vehicles, tow trucks, construction vehicles, street sweepers. The commonality of all these vehicles are these things are disrupting the flow of traffic, and unfortunately, they're being hit on our roads today. Lastly, in addition to the vehicles we're enabling, we also have vehicle-to-infrastructure connecting streetlights and traffic signals to our cloud. Again, this enables safer, faster driving for autonomous and connected vehicles and empowers smart cities, infrastructure, and real-time traffic management. So for the talk today, what we're going to focus mainly on is our dashboard integration. We have a real-time dashboard that we give to our departments, and the dashboard is used by organizations to get a real-time look and feel of what's going on in their city. We give them metrics back, such as the number of drivers they've alerted, the number of incidents that have been created, the average time that they've been on the scene. We have metrics as far as the en route to the incident, how many people they've alerted there, how many runs they've had. We're able to compare these metrics to other organizations and give this information back to the organization so that they can improve their tasks. So how do we get started using AWS? It was real simple. We built an MVP. So we weren't sure what people needed when we first got started. We knew that there was a problem here, and the best way to figure that out was to deploy devices and infrastructure. So with AWS, we literally created an iOS app, connected to Route 53 to the back end, just had an Elastic Beanstalk instance running, load balanced that Elastic Beanstalk. Had a RDS database that we connected to save the information off, and then just had some S3 files for configurations and such. One of the points here is really it was easy for us to go from this infrastructure to the elaborate infrastructure that we have today with the AWS services. And that's a testament to AWS and how easy they make that for you. So as a startup, I would just suggest don't get bogged down in thinking about all the different services and the exact right service that you need to use today, because as you build your MVP, your system's going to change, your requirements are going to change, and most likely what you have today is not going to resemble anything of what you're going to have in a year or so. So I'm going to hand it over to Bill to continue on.
All right, thanks, Jagar. So how did we get from MVP to where we are today? Good question. So when I first came on board at Aws Alert, I learned about some of the new initiatives, such as the dashboard project. I kind of knew we were going to have to start maybe taking more baby steps, stepping stones, to more of the infrastructure that we'll need to support these initiatives. So one of the first things I did was I standardized our applications on Docker, just made repeatable deploys very easy. Once you package up your application and your dependencies into a single Docker image, You have a immutable file system there, mutable container, and it gives you a portability across, different services or different even environments. And then also, of course, isolation. When the container is running, it's isolated from all the other containers, which also gives you great security. So that was really helpful. I think it just gives us the most flexibility to kind of, I like to kind of be agile, and so I like to kind of do things that I know will kind of help us get to that endpoint once we figure that out. So another thing is we were already using Git for, we are using Bitbucket for our Git, for code. Anyway, for code. So I wanted to kind of get us to more of using a CI/CD process, right? So they have that there. So my kind of advice is to really automate, everything you can. It's a little work up front, but as you get going, it's something you appreciate when you're in the heat of the moment and trying to deploy something to production. So one of the main things that we try to automate is, every time we do, whether it's a Git push or a PR, a pull request, create that fresh environment using Docker, of course. Runs through the test suite, and then automatically build all the Docker artifacts, push it to registry, and then just wanted to point out, you could even use other open source third-party, stuff to help you with, managing your deploy process to maybe ECS or something. Also, as previous, the opening speaker, mentioned they got CodeStar, but I think that wraps kind of the code commit, code build, code deploy, and code pipeline services together. So and Jenkins and many others. So there's not kind of one way to just do it. So this is kind of a screenshot of what we see when we look at Redis. And then once all that passes, right, and then it's automation of the creating a Docker image, storing that into ECR, and then deploying that, and then notifying our error tracking thing of a new release.
Yeah, and Bill, to add, as far as the code integration and code deployment, one of the things that we were doing initially was we were packaging up the code bills and deploying those individually every time we would have a code change to production or to any of the testing environments. Obviously, that's a lot of wasted time to begin with. So standardizing on something here for the integration and deployments was crucial for us, and it saved us tons of hours just in the long run. The other thing that it also helped us with quite a bit was identifying issues. So we know that a lot we were deploying to our testing environment, and then we were deployed to our staging environment. Issue would crop up, and we wouldn't know if it was because of the deployment itself, or maybe it was because of something in the code base itself. So this gave us the ability to say, hey, no, the issue wasn't in the deployment, because we know the deployment is repeatable in every environment that we're going to. So that was it was a huge time saving just in the effort of deployments, but then also in troubleshooting and identifying issues. So to Bill's point, definitely standardize on something early for your code deployments and code integrations.
Yep, good point. Okay, so what kind of services do we use now? So we moved from the Elastic Beanstalk to ECS once everything was Dockerized. At that time, if you wanted, there was no EKS, right, at that time, so it was ECS, specifically with EC2. So we did it, though. I think the pros outweighed the cons of, having to set up our own environment, provisioning that, and just managing all that, So With ECS taking advantage of Docker, it made it really easy to just get going and set up an environment. As soon as Fargate came out after reInvent 2017, quickly migrated to that, so I could definitely just X out the EC2 part and don't even have to worry about managing those at all. I like to almost think of it as, it's another step towards the whole serverless, path that everyone's going down right now. And we're such a small team here at Aws Alert. I mean, we're not a big engineering team at all. So whatever time we could save by, using these AWS services, that's more time for us to work on the product for our customers. So another thing I kind of like about ACS, feel like it's very declarative with task definitions. These task definitions are really just JSON documents that basically describe what container you want to run, the environment variables, and what resources you want it to take, and then of course the security stuff. But I mean, it's very declarative. That's what I really like about it. And it's dead simple to hook up, load balancers to your clusters, and then of course, auto scaling just out of the box, as mentioned before. So here's just a quick snapshot of our repositories. So we use an EC2 repository, container repository, ECR. So we have pretty much grouped by project. There's also a couple in there that are strictly meant for the build machine, as Bitbucket allows us to provide a custom image to, if you want to basically customize your build environment, right? Which comes in handy when you want to use third-party tools like the ECS deploy script. So here's, and if you click in one of the repositories, like the dashboard, you'll basically see all of our images that we've basically uploaded. And one tip about this is you always want to tag your Docker images. And a good best practice, I think, is out there is you want to tag it with probably with the git commit SHA, basically, that you get when you commit something or merge something in Git. So, not only does it provide you like a unique ID, but it gives you a way to reference back what code is in that Docker container. So, this is kind of just an overview of just creating a task definition. I mean, as you could see, just giving a name and you specifying Fargate, what memory and CPUs you want, resources you want to use here, specifying the IAM row. What's a cool feature is that you could definitely have multiple tasks, and each of them could have different execution rows. So you could have basically follow the least privileged security scheme. So if you want one task to be able to access like an S3 bucket or something, then you could make that happen. This shows the clusters. So we basically use clusters as a way to separate all different environments, whether they're staging or production. We're not running as many services or tasks as Segment, but we have the capability to. I like to believe so. That's what that's showing. So, what other services? So here's some of the other key services. So just keep thinking back to what we started out with Jagar showed and that other thing, and slowly as we worked on the product for the last year, we've incorporated all these other services. So AWS IoT was a huge one. We wanted to basically start ingesting data from using MQTT protocol. If you're not familiar with MQTT, it's a lightweight message-based pub/sub type protocol. Similar to WebSockets in a way, but it's very good for high latency, unreliable networks. So it's great for IoT devices to be able to talk to, our backends. servers. So we wanted to use that just to kind of decrease the costs and the inefficiency of these devices talking with, via REST with our REST API. So if you could think of it, though, that does create a little more sophistication on the back end because we want to basically ingest two different ways now. So they'll have to come together at some point. So we started then also introducing AWS Lambda because we were also, when we started doing MQTT work, we also serialized a lot of those payloads using Google's protobuf. And so we didn't want any of the other systems, down the line to kind of have to know about the protobuf schema and all that to be able to deserialize the data. So we basically wrote a rule in IoT that sends each data packet to a Lambda function. That Lambda function knows, what kind of payload it is, whether it's like a point, a heartbeat, or an instant location, and then knows how to deserializes it, and then basically then puts it in a queue, and the rest of the system gets it up, takes it, processes it. SNS was vital, right, just to kind of get these events, these messages out there and let it fan out. And then of course SQS, to store all these messages that get fanned out, for other services to pick them up. So MVP to today.
Yeah. So you saw the MVP that we built a couple of years back, and so one of the flows that we identified that we needed was for a real-time dashboard to be able to show where vehicles were when they were in lights and sirens mode, and if they were at an incident or not. So fast forwarding to today. This is just one of the data flows that we have, and so those 4 boxes, we had earlier kind of transformed into this. So we didn't just build this just to build it and do something awesome on AWS. This came out of necessity, right? As Bill mentioned, we went over from a REST protocol to an MQTT protocol. One of the main drivers of that was so that we could reduce our bandwidth. A REST protocol, data transmission could be anywhere from maybe 3K, where when we do that over MQTT, it'd be a few bytes, 20,
like
30 bytes.
75, 80% payload savings.
Yeah, it was quite a bit. And so because of the fact that we knew that we needed to reduce bandwidth, and the other item too is we wanted to make sure that we had a little bit more control over the devices that were being deployed in the field. We decided to use AWS IoT and talk over MQTT protocol. So we kind of replaced that REST API infrastructure, maybe not replace, but duplicate or have another instance of that using MQTT. So we set up AWS IoT on the back end. All of our devices that are in the field communicate over MQTT to that IoT backend, and then we're using the certificate manager on AWS for authorization and authentication of those devices. And it was mentioned before by Mackenzie, just how much you take for granted the devices or the services that you're using here. To set up just those first 3 things that I talked about would probably be over a year's worth of effort if you're trying to do something like that yourself. So understanding what the AWS offerings are and the services are, so that you can utilize them when you need to. I think that's a great idea to learn that. But like I said before, you don't need to use them until you need to use them. And AWS makes it easy for you to kind of go from your MVP to using these different types of services. So after we bring it in from the AWS IoT, we set up some Lambda functions to ingest that data and process it. One of the things that we're doing with the Lambda functions is deserialization. So not only are we using MQTT to reduce that bandwidth, we introduced another layer of serialization to called protobuf which basically condenses that data set even further. And so one of the functions of the Lambda function is to deserialize that information.
Yeah, and so then after that, as I was saying before, it gets put into a queue, and where another ECS backend, basically one of our API platform, basically pulls all that and basically puts in a background job, right, and to basically process each payload as it comes in. Processing, of course, saving it to RDS, and then also doing our notifications to our third-party providers that we work with to send out those alerts. And then also after that's all done, right, it's quickly given SNS so it could fan out to whatever all the other services that need to know about it. And this is where we have right now a queue connected to SNS. And this queue is also pulled then very quickly by another ECS. This is our dashboard product. The back end is Rails, and the front end is in React. It's using WebSockets, so as soon as that packet is picked up from the back end, it's sent over WebSockets to the front end as fast as possible. So that's kind of the process for the dashboard, the near real-time dashboard. I think we kind of want to show you a demo, so we'll get that set up here. A live demo.
Demos.
So this is kind of a screenshot of what the dashboard looks like. But as soon as we could switch over.
How much time does it take when something happens on a device going through that infrastructure?
Well, that's what we intend to show. Not very long.
Yeah, we're seeing sub-second latencies from actually going from an IoT device, traveling over a cellular network, and getting into the AWS backend, and then pushed out back to the client's device. So yeah, it's. I'm not sure who asked the question, but we're seeing sub-second latencies most of the time.
That's kind of what we wanted to show here.
So I don't know where my mouse went. I got the screen up. There it is. So yeah, okay. Thank you. So. Yeah. Okay. So need a lot of devices to do all this demonstration.
Are you?
It's over. Oh, can we switch to this screen, or how do I do that? Sorry.
Yeah. So Jagar has a couple of devices with our client app on them.
Yeah, so we're just using Android devices to mimic the IoT devices that we have. These are using the same protocols, going over MQTT, going over regular cellular networks to talk to our backend. So using this app called Laketo to plug for them to mimic your location on these devices. So I'm just going to hit play here. And you can see the green boxes are moving along. And so basically, when the device goes into alerting mode, the boxes change to orange on the front end here. We have statistics that we're collecting on the devices to know that they're en route, that they're dropping points. One of the things, so as far as the latency goes, I mean, it's kind of hard to tell exactly, but I mean, when I'm pressing this button here, that's how long it's taken for the message to go, from the device through all those AWS services that we described, and then coming back here to the screen. So, it's sub-second latencies with all this data processing, and this is all happening in real time. For our use case, we mentioned that, this isn't last-second crash avoidance, and the only reason we said that is because, to be an onboard sensor, it has a little different connotation than trying to do this over the airwaves that may or may not at some points be reliable. So again, we're looking for that 10 to 20-second look-ahead perception. But as you can see with the latencies that, are shown here with AWS's services, it's much less than that, obviously, or we could do much less than that. And so just to talk a little bit about the data points that we're collecting here. So you can see that this incident here, we have some machine learning stuff going on in the background that identifies when a device is at an incident, and to start broadcasting that incident to service providers. We just collect simple statistics that are displayed here on the dashboard about the runtime to scene, when the vehicle arrived, and the duration. And then when the vehicle's en route, you get a little bit more information as far as the number of alerts it's been sending out, and then just the runtime that it's actively on. So, anything else to add? I think that's it. So I think that's it. So hopefully you guys enjoyed the presentation.
Oh, good. Yeah, round of applause.
Thank you.
We have quite a few questions ranging from the business itself to the tech behind it. So the first is, have you spent any time running this by any of the groups working on the next-gen public safety, next-gen 911, like, I don't know if it's NENA, APCO, and FirstNet? Can you talk a little bit about that?
Yeah, so we're actually, we're on the FirstNet platform already today. So FirstNet has a preemption platform that gives our devices, our IoT devices and cellular devices, preemption when there's a congested network over the cellular networks. So we're actually available on FirstNet via our mobile apps, and we're working with them to get our IoT device on there as well.
And how long is the latency when the primary server goes down and the backup one comes up with an alert? And how do you test that?
We haven't really had that issue yet that I know about. I mean,
No, we haven't. We haven't with AWS, no.
Yeah, so that's a good question.
Yeah. So I mean, we have our load balancers in place. So if we have an issue with the ECS instance, we're able to fail over within within real time with that.
Yeah. Yeah, of course, there is going to be some latency there.
Yeah.
We don't have exact measurements right now, but if something did go down, there would be some latency right now. I mean,
we have failover protocols for those things.
Yeah.
And of course, you have a room full of entrepreneurs. So a big question is, can you talk about the business model of Haas?
Yeah. So kind of generally, what we're doing is we're deploying devices into emergency vehicles. So we're empowering them to be able to broadcast their location and avoid incidents. So some of when emergency vehicles do get in incidents, unlike our vehicles, these are $1 million apparatuses, and they all hit the taxpayers' bottom line. So there's some incentive for the emergency personnel to keep their apparatus safe, keep their citizens safe as well, keep us all safe when they're at an incident or approaching an incident. And then for us as well, we're working with automotive companies and data ingesters where we're able to monetize that as well.
Cool. And people are curious on how do you alert drivers? Is it to their phone, car dashboard, and what's that technology look like?
Yeah, it's a really good question, and that's actually something we're actively working on with car manufacturers today. So one of the screenshots I displayed was infotainment center, infotainment screen where there's a map there, and it had the radio, what the radio station was, as well as half of a map. So really what the question is how do consumers want to be alerted? And so this is what we're working with the manufacturers on. We've toyed with ideas such as audio alerts coming over your system and dimming your music and saying, hey, there's an emergency vehicle on your right. We've also talked about doing a visual indicator, either on the infotainment center itself or in the information cluster in the dash itself. And so some of these newer cars even, they have a full GUI infotainment center there where, we have the luxury of doing some things there. And then, we played with some ideas of vibrating the seats, all sorts of things. So it's still being figured out, but I think we're on the right track.
Awesome. Well, thank you very much for sharing.
Cool. Thanks, guys.